Hello friends, today we will learn about analysis and design of a simply supported rectangular beam in STADD Pro Connect Edition. In the previous lecture, we have seen the working interface of the STADD Pro and we have learned about few tabs that we'll be using in the modeling purposes. So today we will see one problem and we will learn each and every options that are available in the modeling and the design of the simply supported rectangular beam. So let us move to the problem first, and we will see the problem statement first, and then we will go to the modeling part. This is the problem that we are interested in modeling in our software. So we will be analyzing and design a simply supported beam of size 350 mm cross 450 mm for a live load of 5 kN per meter. We will be using M20 and Fe415 steel. So in the report we also need bending moment and shear force diagram. So we will be generating that report, and the span of the beam is given as 10 meter. So obviously for bending moment and shear force diagram we need the span. So let us see how we can model this problem in the STADD Pro. So this is the STADD Pro Connect Edition. When you will open the file, you will get a STADD Pro Connect Edition in this frame. So first we will go to the configuration and we will see that whether our units are in metric or not. Yes, it is in metric and global axis in the Y up direction. So after clicking on the OK, we will go to this new file because we will be modeling a new structure in our case. So let us click on this and we need some model information. So let us write the file name as simply supported beam, and the location, as I have already selected this location earlier, so STADD Pro has directly collected that location. It is in the desktop and it is in the STADD folder. You can change this at any time. Unit is metric, and after filling this we will click on this option create. So once you will click on this, you will be directed to a new window, and here you can model your beam. So as we can see that we will be modeling a beam of 10 meter whose size is given to you. So before going to the modeling, we have to understand how the STADD Pro software understands our command. So usually that in a beam we have two supports, that is one support is at one end, another support is at another end. So these two supports will be treated as node in STADD Pro software. So whatever the model we will be creating in STADD Pro, we first have to create node for that. So this is a very simple structure, and this is a simply supported beam. So it has two ends. So one end we will have one node, at another end we will be having another node. Now there are different ways of creating nodes. We will see each and every options one by one. So at the right hand side you can see there is some options of giving some nodes here. So this you can directly put in this boxes as per your need. So here you can see as I have clicked, so it has directly taken as origin as the first node. So and moment this origin has been clicked here, you can see a node has been created here, a small black dot. It can be visualized that this is the first node. Now if you want to click on the second node, so I will write here 10 because our beam is of 10 meter, and you can directly write 0 here, or if you press enter it will be automatically, it will take 0 0. That means Y coordinate will be taken as 0 and Z coordinate will be taken as 0. So moment you have clicked here, so this is the first coordinate at 0 0 0, this is the second coordinate at 10 0 0. Now these are the two nodes that has been created. Now you can see the axis system in the STADD Pro also. This is the X axis, this is Y axis, and this is Z axis. So our Y axis is in the upward direction. Now here you can see here all the three axes are shown in this figure. Now we can change the views in our STADD Pro. For that we will go to this view tab, and here you can see currently all the tabs are not functioning. So for if you want to make them function, just click anywhere on this white window and it will be then highlighted. So here you can see this is the view option. Now if you click, this is the isometric view, so all the three axes are shown in this case. So if you click on this is the front view. So here you can see these two axes, two nodes you can see from the front side. Now if you click on this, that is the left view, then only one node can be seen, because one node will be at the back of this beam. Similarly, from the top you can see these are the two nodes, from the bottom you can see there are two nodes, but from the right hand side you can see only one node. So let us work on this front view so that we can actually visualize our drawing. So these are the two nodes, this is node number 1, this is node number 2, and now we need to add beam from this node to this node. So for that we will go to this geometry and we will click on this add beam option. So you click on this. The moment you will click on this add beam option, you can see the notation of the cursor has been changed. Now you will click on this node and you will click on this node, then a beam will be added within these two nodes. And here you can see at the right hand side, beam number 1 there is between node A to node B. Let us see how you can create nodes with a different option. So for that we need to delete this beam first, and then we will see how you can create nodes apart from this option. So for that let us delete this beam first, and to delete this beam you just need to click on this beam. It will be get highlighted, and use the delete key from your keyboard. So when you will click that, prompt will be asked by the STADD Pro that whether you want to delete this beam. Yes, we want to delete this beam, so we will click on this OK. And since this beam consists of two nodes, so the STADD Pro asks you that whether you want to delete the beam along with the nodes or you only want to delete the beam. So we want to delete the beam as well as the nodes, because we will be creating the nodes with a different option in this case. So yes, we will be deleting the beam as well as the nodes associated with the beam. So we will click on this. If you click on the node, then only beam will be deleted, node will not be get deleted. So let us click on yes. So here you can see the beam as well as the nodes has been deleted. So now we will click on this, we will create our first node. So let us take our first node at origin, enter. Now our next node is at a distance of 10 meters from this node along x-axis. So we will select this node first, and then we will use an option. Now to select a node, there is an option that you need to drag your mouse along a window so that this node gets selected. Now, but before to select this node, your cursor has to be in a node cursor. So for that we will go to this select option and we will use the node cursor. So if you click on this node cursor, so any drawing you will be selecting only nodes, then we can choose this option node cursor. So if you are clicking on this node cursor, then only nodes will get selected. So we have to click in this node cursor and then drag your mouse so that your selected node is under this rectangle. So here you can see this node has been highlighted, that means this has been selected, and here you can see this is in a black color, so that means this has been selected. Now we will use Ctrl C and Ctrl V. So when you will use Ctrl C and Ctrl V, then a window will get prompted and you will be asking only to put the distances where you want to copy this node. So we will put it x equal to 10 and y is 0, z is 0, and we will keep it OK. So here you can see this node has been copied from this point to this point. So we can use this option also, Ctrl C and Ctrl V. This is copy paste option. Now since this node has been created, we will again go to this geometry tab and we will add beam between these two nodes. So we will click on this add beam option and we will click on the first node, we will go to the second node, we will click over here. So this node, between these two nodes, the beam has been added. So once the model has now been created, so we will now assign the properties of the beam that has been asked in the problem. So in this case, we are having a rectangular beam of 350 mm cross 450 mm. So overall depth is 450 mm and 350 mm is the width of the beam. And we are designing this beam for M20 and Fe415 steel. So obviously our material is concrete, and span of the beam is already been taken as 10 meter. So after this thing, we will go to the property tab here. In the analytical modeling, you can see we are currently working on the geometry option. Now we will go to this properties tab. We will click on this properties tab, and here in the right hand side you can see there are various options available. We will see these options one by one as per the problem, but in this case we have to first define our section properties. So for that we will go to this define option. So we will go to this define option. Here you can see a new pop-up has been generated regarding the property of the beam. So in this case we are having a rectangular section. If somebody is having a T section, they can select it as per their demand. For trapezoidal section, for tapered I-beam likewise. So now let us see the rectangular section. So in this case we are asked to put our value of YD and ZD. YD stands for overall depth, ZD stands for overall width. So in our case our YD is 450 mm, but here the unit is in meters, so we will write down 0.450. This is 450 mm, and for ZD it is 0.350. So material is concrete. You have to keep it in mind that whenever you are giving this property, make sure that this option is checked. If this option is not checked, then do assure that this option is checked. Otherwise the material elastic modulus will not be get assigned to this beam. That is the modulus of elasticity of the concrete. So we have checked this option. We will click on this add option and then close. So here you can see a section has been added here. This is reference number 1, rectangular, 0.45 into 0.30, and the material is concrete. Now we have to assign this section to this beam. Now there are different methods of assignment. There is assignment method here. So there are different methods. One is assigned to the selected beam, second is assigned to edit list, third is assigned to view, and fourth is use cursor to assign. So there are different ways of assigning this material section to this beam, and for that we will be using this different methods which are been given in the STADD Pro. A very good and appropriate way is that you select this beam and then you use any one of the 4 options. So let us select this beam first by clicking on this beam. Here you can see this beam has been highlighted with red color. Now the assignment method, the assign to the selected beam option we will be using. So since there is only one beam, so we are using this assign to the selected beams, and this is highlighted. We will use this option assign. The STADD Pro will ask you that whether you want to assign to this beam or not. Yes, we want to assign, so we will proceed. And here you can see this property has been assigned to this selected beam. We will also learn different options available here in the STADD Pro also in next problems, because all the 4 options are equally important, because maybe in any problem you will find that assign to view is more easy, and in another problem you will find that use cursor to assign may be easy for you. So we will learn each and every options one by one. In all other problems we will see in our next lectures. After the properties has been assigned, we will go to the support option here, supports. So we will click on this. Here you can see again in our window there are no support at initially. We need to add those supports here, and then we will assign one by one to our joints. So we will click on this create option, and here you can see various types of options are available for various types of supports. Usually we are interested in fixed, pin and roller type of support. So in the STADD Pro we have this fixed support. Here you can see that all the values of fx, fy, fz, mx, my, fz has been restrained. For pinned support, here you can see moment has not been restrained, but fx, fy, fz has been restrained. This fixed but support is used for rollers in our case. So but there is an option of release. So we all know that in a roller support only vertical reactions are getting generated. So in that case we will be releasing fx, fz, mx, my. That means all the moments and all the forces along x and z direction will get released. So we will check these options to make our fixed but option as a roller support. We will add this. So if we will creating two types of support in our case as per our problem statement. So we have a simply supported beam, so we will be having a hinge support at one end, and at another end we will be having a roller support. So for that we will be creating these two supports one by one, and then we will assign this support to each and every node. So first we are creating the roller support. Here you can see we are using the fixed but option. So this is for fixed but option. We will release fx, fz, mx, my and mz. We will click on this add tab. Here you can see this roller support has been added here. We will again click on this create. We will click on pinned and we will add. So these two support has been added, but these two support has not been assigned yet. So we have to assign these supports manually to these two nodes one by one. To assign these supports to these nodes, we will select the node first, and then we will select the concerned support, and then we will use the assignment method. So let us select this node first. So we will drag our mouse. Here you can see when we are dragging the mouse, this node has been selected. Now we are interested in assigning the roller support to this node. So here you can see this is already been selected now. And this assignment method, there are 4 different methods of assignment. So we are using this method, that is assign to the selected nodes, because this node has been selected. So this method has been highlighted. So assign to the selected node, and this has been selected. Here you can see this is in blue color. So that means this support has been selected, and we will use this assign option. So we will click on the assign. Here the STADD Pro asks that whether you want to assign. Yes, we want to assign, and here you can see this roller support has been assigned here. Similarly, we will select this support first. This has been selected, and then we will select this node. Here you can see this node has been highlighted in red color. That means this node has been selected, and we will use this option, that is assign to the selected node, and we will click on this assign. So STADD Pro will ask whether you want to proceed. Yes. Here you can see these two supports has been assigned to the selected nodes. So once the support has been assigned, we will now move forward for loading on the beam. So here you can see we will move to this option of loading. So when you will click on this loading option, the load definition tab will open, and there are different options given here. We will see each and every options in successive problems. In this problem we have to first define our load cases. For that we will click on this load case details, and after clicking on this load case detail we need to add. So we will click on this add option. So another pop-up will be generated, and here we have to add the load cases as per our problem. So this is a very simple problem. Here only live load of 5 kilonewton per meter has been given, but along with the live load we have to add dead load also, and it is always advisable and recommendable to add dead load also for proper designing of the beam. So first we will go to this loading type dead. We will write this title as dead load. We will write this title as dead load, and we will add this. And again we will go to this loading type live, and we will write the title as live load, and we will click on add, and then we will close this tab. Here you can see two types of load cases has been added. So one is dead load, another one is live load. Now we will assign the values of this one by one. So let us click on this dead load and click on this add option. Here you can see load items tab has been opened, and here you can see the self weight option has been automatically opened. So here you can see we will apply the self weight in the minus y direction. So here the direction is y, but the factor -1 has been taken. So this dead load will be acting on the -y direction. So we will add this. Here you can see this has been added, and we will close this. Now this self weight in the -y direction has been added in the load case details, but this has not been assigned yet. So I will assign this later on. First I will add this live load also. So let us click on this live load. Let us click on this add. So we have to apply a live load of 5 kilonewton per meter. So we will use this member load option, and there are various types of loading options given in the member load. Our case is a case of UDL, so we will be using this uniform force option. So let us click on this uniform force, and here the value of W1 needs to be given. So in our case the W1 is -5, and minus stands for that the load is acting in the -y direction. Direction here by default it is checked as GY. GY stands for global Y direction. So in any member, if it acts on a local Y direction, then we will be using this Y local, but currently we will be using this GY. And since the load is applying for the entire span, so in that case D1 D2 is 0. D3 stands for the load is acting at the center of the beam, so we will be using D3 also 0. If any problem the UDL is not acting on the entire span, then we will be correspondingly we will give the value of D1 D2 and D3. So here you can see that in the load definition tab, two loads have been added. One is the self weight, that is the dead load. Another one is the live load, and it's of uniform force in the global Y direction of value -5 kilonewton per meter. But these two loads have not been assigned yet to the beam because there is a question mark in front of the loads. So this question mark says that this load has not been assigned yet. So we have to assign these loads one by one to the beam. So for that, let us select this beam first by clicking this beam. So this beam has been highlighted, so this has been selected. Now we will use this assignment method. So we will use the assign to the selected beam option, and then we will use this self weight first, and then we will use the assign key. So STADD Pro will ask you whether you want to assign this. Yes, we want to assign. So this self weight has now been assigned, and this question mark has been removed. Similarly, we will select this beam first. So and we will use this assignment method, that is the assign to the selected beam, and then we will use this global Y direction -5 kilonewton, that is the live load, and we will use this assign method. Click on yes. Here you can see a UDL of -5 kilonewton per meter is acting on the beam, and this is the live load. So after the loading has been assigned, we will move to the analysis part. So here is the analysis option. Let us click on this analysis option. So first we have to give some commands for analysis. So for that we will go to this define command option. So let us click on this define command, and in the analysis print command there are various types of options. So we will, by default it opens in perform analysis, and in the perform analysis we are currently not interested in any print option. So let us click on this no print option. If you wishes to click on print option, you can click on all, but currently I am not interested in any print option, so I will use the no print option, and we will click on this add and close. And in the post analysis commands, let us click on this post analysis commands. So let us click on this post analysis command, and here we will also define one command, and in that command we will see this analysis result. So let us click on this analysis result and click on the add, close. So these two commands has been added in the analysis options. One is perform analysis and second is print analysis result. After that we will click on this run analysis options. Here you can see there is a shortcut key for that, that is Ctrl+5. You can directly click it from your keyboard, or you can use this option, run analysis. So let us click on this, and here the STADD Pro has analyzed the result. Here you can see there is 0 error, 2 warning, 2 notes. And we will click on this view output file, and then we will click on this done. So after that, output file will be opened. Let us maximize this, and here in the left hand side in the content you can see we have results, we have run analysis results also. So analysis result, we will double click on this, and then we will directly move to that line number 94. And here in the STADD Pro output file, here you can see we have started our job informations, and this is the type of material, everything is given in a particular line number. And we can directly move to this analysis result. Double click on this. Here we can see we have moved to this line number 94, and this is the joint displacement. So we are getting a joint displacement with various nodes, Z rotation, X rotation, Y rotation. And similarly in the support reaction, we can see that we are getting support reactions in joint number 1, that is for load 1, for load 2, likewise. So these are the different analysis result, and this is the output file. So let us close this first, and then we will move to the post processing. So let us click on this post processing part. Here you can see in the workflow in the left hand side we have a post processing tab. Let us click on this. So after that you will get a pop-up window here. These are the load cases. Here you can see in this problem we have selected only 2 types of load. One is dead load, another one is live load. And make sure that these 2 loads are in the selected window. In many cases you will find that these 2 loads are in the available window. For an example, if these 2 loads are in this window, then these 2 loads should be in the selected window. So here you can directly click on this, and you will be directed to this selected window. So 2 loads on which the design has been done for this problem, they are to be taken in the selected window, and then we will apply and OK. So based on these 2 loads, the STADD Pro will post process the design part and on the analysis part. So here you can see these are the post processing part, and we have displacement, we have reactions, we have beam results, likewise. So let us see this one by one. So by default it opens in displacement. So these are the values in the X and Y direction. Here it is a rotation in Z axis for dead load and for live load, and these are the all relative displacement, maximum displacement in given as per the distance from the node. So let us maximize this first. Here you can see this is the deflected shape of the beam. So in the post processing we can see the deflected shape of the beam. If you want to know the maximum displacement at the center, then we have to go to this option, that is Annotate. So click on this Annotate option. Here in the beam result option there are various types, that is bending, shear, axial, displacement. So we have to check this option, that is the maximum displacement, and then we need to go for Annotate. Close this. Here you can see the maximum displacement of 11.216 mm is showing in this deflected shape. And if we want to know the loading diagram or the loading pattern for report generation, for that we first have to close this displacement option. Here it will be closed. If you click on this displacement tab, again it will be shown. So let us close this first, and in the view loading diagram we need to click on this view loading diagram. Here you can see this 5 kN per meter of UDL is acting, and it is showing in this loading diagram. And if we want to also show the node to node distance from node 1 to node 2, for that we have to go to this option utilities, and in the utilities tab in the node tool option, here you can get node to node distance. So after clicking this node to node distance, click on this node number 1, click on this node number 1 and click on this node number 2. Here you can see from this node to this node the distance 10 meter is showing in this diagram. So now we will take the picture of this for report generation. So for that, right click on this, and here you can see, or right click on this, you will get take picture option. Here in the ID you can write it loading diagram, and in the caption you can also write the same, that is the loading diagram, and then click OK. So this loading diagram is now, picture of the loading diagram has now been taken. Now we will come to the displacement here option, and let us click on this loading diagram and remove this node to node distance. For that we will again go to this node tool and remove this node to node distance, and then again we will go to the result option and click on this displacement. So this is the displacement, maximum displacement. Take the picture again, write it down here, displacement, and in the caption we can write maximum displacement. So this is two pictures we have taken. One is for loading diagram, another one is for displacement. Now click on this reaction part. So let us click on this reaction, and here we will, in the right part we can see various types of reactions that is getting generated. So first, maximize this window. Here you can see these are the two supports that we have already created in the modeling. So one is roller, another one is hinged. So here you can see the total load was 50 kilonewton. So 25 kilonewton, 25 kilonewton we are getting in the y-axis. So let us click on this annotate part first, and in the beam result we can get, in the reaction option we can first close this global X and global Z, because in our case we are only having a vertical force, so we will not get horizontal reaction in this case. So let us close this, and in the bending we can close global RX and global RZ, and we can also show in diagram. So if you want to show this in the diagram, then we have to check this show line, and when we have to also give some scaling. So for initially we can use 25 kilonewton per meter per meter, and then we can use the annotate option. So here you can see these are the reactions that is getting generated. If we want to give this reaction along with the loading diagram, then we have to click this view loading diagram option. So here you can see the loading diagram of 5 kilonewton per meter is acting, and here 25 kilonewton of reactions are getting generated. We can take the picture again. So right click on this and take picture. So let us write this as reaction forces. Okay, now we will move to this beam results. For here let us click on this beam result part, and let us maximize this window. Here you can see this is the bending moment diagram of the simply supported beam. Now if we want to know the maximum value of the bending moment diagram, we have to again click on this annotate option, and in the beam result we have to check this maximum value, because in this case at the ends we know that the bending moment will be 0, so we are not checking, we are not clicking on this. But in the case of fixed beam, if the ends moments will be generated, so in that case we can check this option, and let us annotate this, close. So here you can see the maximum moment of 62.5 kilonewton meter is getting generated here, and if you want to wish to draw the take the picture along with the loading diagram, then click on this. Here you will get, this is the UDL, and for that bending moment is getting, we are getting a 62.5. Now if somebody wants to show the bending moment at the end, for which it is obviously 0, then for that we will again go to the annotate option, and that we can check this option as at the end. So we can see that at the end we are getting 0 moment. So we can take this picture again. So let us write this BMD, and let us, this is bending moment diagram. Okay, now once these all are open, we can go to the shear force also. For that we can click on this F5. If we, because here you can see there are 3 tabs in the shear values and 3 tabs in the moment values. So here MZ we are getting. Now if we click on this F5, then shear force diagram will be on, and if we close on this MZ, then bending moment diagram will be off. So if we close on this loading diagram, then loading diagram will be off, but here values are not showing. So for that, if we press our control key and the wheel of the mouse, we can increase this diagram value. So this is the shear force. If you press your control key and rotate the wheel of the mouse, you can increase your diagram scale. And then if you want to give the values at the ends, then we have to go to the annotate option, and we will again go to the beam result, and in the shear we can see this at the ends. So let us click on this. Okay, close. So here you can see 25 kilonewton is the shear force at this point, because this is a simply supported beam, so the shear force at the end will be equal to the reaction forces. Now if we want to take the picture of this, right click, take picture. We will write SFD, we will write here shear force diagram. Okay, now after all values, we will go to this report option here. Let us click on this report, and in the report option we have a setup report tab. Click on this setup report tab. So here in the report, what we want we can add, or what we don't want we can delete. So first input value is the job information, this is okay. We will go to the output value here from the available list. So in the output value we want beam displacement summary, then we will click on this, and we can find beam maximum shear force, we can take it, and we can find the values beam force, beam bending details, maximum beam maximum moments. This is we want. If you want anything else, you can add as per the list available. And from the pictures we want all of them, so we will directly use this double arrow, so all of them will be directly selected. Make sure that whatever the options you are having in the selected window will only be printed in the report. Now if you want to rearrange the terms as per your custom, then we can also do it from these 2 arrows. For an example, if loading diagram and after that we want reaction forces, then we will click on this and then we will use this arrow, then reaction forces will be generated in the report first and then displacement. For an example, if we want shear force first and then bending moment, then we can do like that, and then we will click on the part OK. Once this is over, then here you can see the report is being generated. So in the print report option, we can click on this print report and we can save wherever we want. For example, we can change it to Microsoft to PDF and then click on OK. So once PDF has been converted, we can give some file name. For an example, simply supported beam, and we can store it at a place in the folder where we want. For an example, currently I am saving in this STADD file, so we can save it here, and this is the report that we are getting. So these are the maximum bending moment. This is the loading diagram. Here you can see with caption it comes loading diagram, and shear force, maximum displacement likewise. After analysis, let us see how we can work on the design part of the simply supported beam. Before going to the design part, just we can see in the post processing tab. So here we have clicked the post processing tab, and in the beam result, if you click on this beam, double click on this beam, then you will get detailed information about the geometry, property, loading, deflection, everything. For example, by default it opens in the geometry. So here you can see the length of the beam is 10 meter and the overall depth is 450 mm. And if you click on this property, you will get various properties of this beam. And similarly, you can see this area of cross section, and you will get the moment of inertias. Loading, we can say, since we have taken two loading cases, one is dead load and live load, then we can check as per our details. For example, we can check the dead load, that is the self weight of the beam, and if we click on the live load, we will get that UDL of 5 kN per meter. Similarly, in the shear bending, we can see that this is the bending moment diagram of the beam, and this value corresponds to the value for the dead load. So if you change this to live load, you will get a different value of for live load bending moment. And this is the bending moment distribution from the distance from the support. So if you click on this shear Y, you will get the shear force diagram for live load. And similarly, if you choose dead load, you will get shear force diagram for dead load. Now similarly, this is the deflection. Here you can see currently there is no deflection showing because the direction chosen by default is in X direction. So if you choose in Y direction, you will get the deflected shape for dead load. Similarly, for live load, you will get a deflected shape. Now we want to include the design part of the simply supported beam. So let us close this tab once and let us go to this analytical modeling, and here you can see there is a design option. Let us click on this, and by default it opens in steel, but since we are working on the concrete, so we will choose this. So this is the concrete design. So when you will choose this, the current code of IS456 will be automatically taken by the STADD Pro software. Now there are three different tabs here: select parameters, define parameters, and commands. So we have to choose one by one each and every tab, and we will assign those. Let us choose on select this first option, that is the select parameter. Let us click on this. When you will click on this, you will get various parameters. By default, all the parameters are selected first. So first we will unselect them by double clicking on this arrow. Now whatever parameters we require for our design, we will choose them. So for an example, we require compressive strength of the concrete, so we will click on this compressive strength. Then we required Fy main, we will choose this, that is the yield strength of the main reinforcement. Similarly, Fy sec, we will choose the yield strength of the shear reinforcement. Then we can choose the clear cover from the outermost bottom reinforcement. We can choose it like this. Okay, so let us, these parameters has been selected, and then we will click on this OK. Now whatever the parameters we have selected, we have to define the values of those parameters. So for that, let us click on this define parameters. So here let us select this FC. So FC is the characteristic strength of the concrete. So for M20, because as per our problem we have M20 grade of concrete, so 20 Newton per mm square, but here the unit is in kilonewton per meter square, so we have to add 3 zeros. Add. Now we will take Fy main, so it is 415, so we will add 3 zeros. Fy sec is also 415, so we will add 3 zeros. And it is clear cover from the bottom is 25 mm, it's okay as per the codal provision, and let us add close. Now these things need to be assigned. Now green tick means it has already been assigned, so we have to choose this FC, and we will choose any one of the assignment method. Now let us use another different method. Now we have used this method earlier, that is assign to the selected beams. For that we select the beam first and then we use this method for assignment, but now we will use this method, that is assign to view. Now in this method, anything in which the structure is in view, that will be assigned directly. So here right now we have only one beam, so we will use this option, that is assign to view. So first click on this and then we will use this and then assign. So here you can see this FC has been assigned to this selected beam. Now again we will use this assign to view, and let us select this and use this option assign. Computer will ask you whether you want to assign. Yes, here you can see the green tick shows that this parameters has been assigned. Now we will select this assign to view first, and then we will click on this option and then we will use assignment. Here you can see all the options have now been checked. Now we will go to this command option first, and whatever we want to design will be given in our output file. So we want to go for design of the beam. Let us add this, and here there is no column, so we will not do this. We will not take any slab element. Quantity takeoff we can add, close. Now these two quantity takeoff is already been checked, but design beam is again under question mark. So we have to assign computer or the software that which beam we want to design. Now here only one beam is there, so I will again use this option assign to view, and we will check this and we will use this option assign to view. So here now everything has been checked. So now we will again run this analysis option. Structure has been modified because we have run our analysis earlier. So if we have updated anything, then structure will be modified and everything will be saved. Yes, save. Now let software will run the analysis again. Here you can see we have 0 error, 2 warning, 2 notes. And now let us close this first and let us go to the post processing. And in the post processing, in the beam result, if you double click on this beam again, now apart from these options, now you can see there is another option of concrete design, which was not earlier showing. So let us click on this concrete design. Here you can see the structure, the STADD Pro is giving you the design part of the simply supported beam. So at the top it is giving 4 reinforcement. At the bottom they are giving 4 reinforcement, and these are the design parameters. For F5 we have chosen 415, for FC it is 20 megapascal, and these are the shear reinforcement, which is 8 mm bars at the center to center, and the spacing is 255. So this is the design part of the beam as per IS 456 2000. And here you can see at the bottom you can see they are using 12 dia bars, and at the top it is taking 10 mm dia bars. So this is the design part of the beam. I hope you all have learned this. So in the STADD Pro you need to go for practice. Each and every problem is to be practiced. Each and every command has to be learned by your own. So I hope you will practice this problem by your own, and if you are having any problem you may share it in the comment box. I will discuss with you all. So let us wait for another question that I will come in our next lectures, and we will see some problem of continuous beam. Thank you all.